Alright, today I'm going to do 10.4, which is hyperbolas. With the conic sections that we did before, we were cutting the cone straight across, gave us a circle, and at an angle, gave us the ellipse. Both of these had plus. With a circle, we had the same movement in all directions, but the plus brought it together. With an ellipse, we had a slightly different movement vertically and horizontally, but the plus still brought it together. With hyperbolas, we're actually going to be cutting two cones on top of each other, like an hourglass. So I have this cone right here, and I'm going to cut it straight down. This straight down cut is going to make a shape like this right here, and also down here. So we're going to have something like that. So what a hyperbola looks like, a very, very badly drawn one, is like that. It's very crude, so don't pick on me. The difference between an ellipse and a hyperbola in the equation is the ellipse is coming together, hyperbolas are going apart. So instead of being plus, we're going to be minus, okay? So our equation is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. And the only difference between this and the ellipse is that this has a minus sign, the ellipse would have a plus sign, okay? This is a horizontal. It's horizontal because the x is coming first. Well, it's horizontal because the x is positive and the y's are being subtracted. That's why it's horizontal. A vertical one would be switch the order. So just like on the ellipses, when we talk about the actual equation, we do make the a value come first and the b value come second. But what's really important is that when you're doing your movement, on this one for my vertices, I'm doing the movement to the y. On this one for my vertices, I'm doing the movement to the x. That's the important thing. With hyperbolas, the vertices don't have to be, the movement doesn't have to come from the larger number. So b squared can actually be bigger than a squared, which is not the case on the other one, okay? So let's go through the process of figuring out the information. Here's my poorly drawn vertical hyperbola, and here's my poorly drawn horizontal hyperbola, okay? This one gets the equation y minus k squared over a squared minus x minus h squared over b squared equals 1. This one gets x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so let's do the movement. The center is going to be at h comma k, and that's true for both of them. I do still have vertices on both of these, but what I don't have is co-vertices. So remember, the co-vertices were your less movement. We're not going to have that, okay? But we are going to have vertices. So our vertices on this one are going to be at, it's happening to the y, so it's going to be h comma k plus or minus a. And this one, the vertices are happening on the x, so it's going to be h plus or minus a comma k. All right. We also need to find the foci. Our foci is slightly different on this one. On the ellipse, we wanted to do a squared minus b squared. But if you notice here, what's really happening is I have my center here. I don't want to subtract it away because that's not going to get me inside, and I want my foci to be inside. So we're going to do a squared plus b squared. So for the foci, first we have to do a squared plus b squared equals c squared, and that's the same on both. And then the foci on this one, it's going to be a movement on the y, so it's going to be h comma k plus or minus c. And on this one, it's going to be on the x, so it's going to be h plus or minus c comma k. Okay, that's the major parts, the vertices and the foci. Now we need the equation of the asymptote. So we do have two asymptotes that come through here, and they cross right at the center. Why I said this was poorly drawn is that my hyperbola actually should get infinitely close to these lines, so it should be much more like this. Okay, and the same thing's true over here. We're gonna have these lines that come through right at the center, and the hyperbola is going to get infinitely close to that. Okay, so how do we find that is, for this one, we're going to do y minus k equals, remember that your slope, the slope of a line is always y over x. So our movement for the slope of this is going to be the a, it's under the y, over b. So a over b. Notice that I have one positive slope and one negative slope, so we put plus and minus, a over b, parentheses, x minus h. That's the slope of the line. Or, well, that's the equation of these two lines. And for this one, it's going to be a little bit different. The asymptote is going to still be y minus k equals, it's still going to be one positive, one negative. But notice that this time, the letter under the y is b, so this is going to be b over, and the letter under the x is a, x minus h. So the only difference between them is this one, the a is under the y, so a is on top, and this one, the b is under the y, so the b is on top. And that's the only difference between those two equations. So that's all the information for hyperbolas. They are kind of complicated. Drawing them out are kind of complicated. Doing all this stuff is kind of complicated, so we do need a lot of practice, and we will get a lot of practice. What we want to do is we want to go through the process, and I'm going to do that on a separate video because this one's already kind of long.